October 3rd, 2025, right now. Multiple spacecraft at Mars are pointing their cameras at something that shouldn't exist. An object streaming 150 kilograms of gas per second with zero recoil. Like watching a cannon fire without kickback. A violation so fundamental that when scientists first saw the data, they assumed their instruments were broken. They weren't. Harvard's Avi Loeb has rated it a 6 out of 10 on his alien technology scale. But that's not why you're here. You're here because 2 days ago, someone claiming to work with the European Space Agency leaked something on 4chan. Technical, detailed, frustrated. They described a formal working group that has tried and failed to make this object fit any known class of natural body. Quote, "This position is no longer tenable, and the silence from leadership on the cognitive dissonance this requires is becoming a serious professional issue." They talk about chemistry that shouldn't be possible. Nickel tetracarbonyl, a synthetic industrial compound, streaming off a rock that's supposedly billions of years old. Dust so strange it took a week of recalibration before they'd accept the measurements were real. And a mass problem. 33 billion tons compressed into 3 kilometers. Statistical odds so bad that either our models of the galaxy are wrong by a factor of 10,000, or this thing isn't debris at all. But here's what makes it worse. In 26 days, it disappears behind the sun, the perfect window, hidden from every telescope on Earth, and when it comes back in December, we'll know if it changed course. Because if it did, nothing natural can explain that. There's a theory, one that sounds like science fiction but explains every single anomaly, the outgassing with no thrust, the synthetic chemistry, the thermal impossibility, an object with its own internal engine, not powered by the sun, powered by something from the Big Bang itself. And it's testable. 2 predictions, both falsifiable, both coming within the next 3 months. This is 3I-ATLAS, the third interstellar object we've ever detected, and the first one that's made scientists question whether they are looking at a comet or something pretending to be one. By the end of this, you'll understand why some researchers are no longer sleeping well, why the trajectory looks designed, why the timing is too perfect, and what happens if the data keeps refusing to cooperate. Because the walls are cracking, and the shape of the room is starting to show. If you're ready, hit that like button and subscribe, because this story is happening in real time, and tell me in the comments where you're listening from, what time it is there, and the weirdest thing that ever happened to you. Chapter 1, The Mars Moment. Something is happening right now. Not tomorrow, not in some distant future scenario where we finally build the right telescope or send the right probe. Right now, today, October 3rd, 2025, at this exact moment, humanity has multiple spacecraft positioned around Mars, and every single one of them is attempting to photograph the same object. The object is called 3I-ATLAS, the third confirmed interstellar visitor to our solar system, and at 4 universal time this morning, it passed within 29 million kilometers of Mars. That's the closest it will come to any planet during its entire journey through our cosmic neighborhood. The timing is critical. Let me explain why. For the past 3 months, scientists have been watching this object with Earth-based telescopes. Hubble captured it. The James Webb Space Telescope analysed its chemical signature. Dozens of observatories around the world tracked its movement. But there's a problem with all of that data. Distance. When Hubble photographed 3I-ATLAS on July 21st, the comet was 446 million kilometers away. That's roughly 3 times the distance between Earth and the Sun. At that range, even Hubble's incredible optics can only resolve so much detail. But today, something changed. The Mars Reconnaissance Orbiter, equipped with the HiRISE camera, is now 20 times closer to 3I-ATLAS than Hubble was during its observation. 20 times. The difference in resolution is staggering. Where Hubble could see a fuzzy blob surrounded by dust, HiRISE should be able to resolve details down to 30 kilometers per pixel. If the object is truly as large as some calculations suggest, 5 kilometers or more in diameter, we should see structure, shape, maybe even surface features. The European Space Agency is also involved. 2 spacecraft, Mars Express and ExoMars Trace Gas Orbiter, have turned their instruments toward the comet. Mars Express carries the high-resolution stereo camera. ExoMars has the colour and stereo surface imaging system. Both were designed to photograph the Martian surface, but for this brief window they're aiming at something far more unusual. And then there are the spectrometers. Mars Express has Omega and SpyCam. ExoMars Trace Gas Orbiter has Nomad. These instruments don't just take pictures, they measure light. Specifically, they break down the light reflected or emitted by an object into its component wavelengths. That data reveals chemistry, what molecules are present, what temperatures exist, whether the activity we're seeing is driven by ice sublimating or something else entirely. The hope, the official hope, is that these observations will settle some basic questions. How big is the nucleus really? Is it rotating? If so, how fast? What does the dust cloud actually look like up close? And most importantly, is this just an unusually large comet behaving in unusual ways? Or is there something fundamentally different about this object? Because here's the tension. Based on brightness alone, when 3I-ATLAS was first discovered in July, astronomers estimated it could be up to 20 kilometers in diameter. Then, as better data came in from the Vera Rubin Observatory, that estimate dropped to 10 kilometers. Then Hubble observations in late July suggested maybe 5.6 kilometers, and some models, depending on how reflective the surface is, suggest it could be as small as 440 meters. That's a massive range, 20 kilometers down to under half a kilometer. It's the difference between a small city and a large building, and the answer matters a lot. If 3I-ATLAS is truly 5 kilometers or larger, it becomes the most massive interstellar object ever detected by several orders of magnitude. The first interstellar visitor, Oumuamua, was estimated to be around 100 meters across, shaped like a pancake, tumbling through space. The second, 2I/Borisov, was maybe 600 meters, relatively normal-looking comet. But 5 kilometers? 33 billion tons? That's not just big, that's statistically problematic. Let me put this in context. Our current models of how interstellar objects form suggest that smaller debris should vastly outnumber larger objects. For every mountain-sized rock ejected from a distant solar system, there should be tens of thousands of pebble-sized fragments, maybe hundreds of thousands. The detection probability is weighted heavily towards smaller objects appearing first, simply because there are so many more of them. Yet here we are, 3 interstellar objects detected so far, and the third one is potentially 1,000 to 1,000,000 times more massive than the first. That's backwards. Unless our models are wrong. Unless the galaxy isn't just dotted with interstellar debris, but swarming with it. Unless the processes that eject material from solar systems are fundamentally different than we thought. Or unless this object isn't debris at all. That's the question the Mars observations are supposed to help answer. If HIRA-C captures a clear image showing a 5-kilometer nucleus, the mass estimates hold. 33 billion tons becomes a hard floor, and at that point the statistical anomaly becomes unavoidable. If the image shows something smaller, say a kilometer or less, then the mystery shifts. Because a smaller nucleus with the observed brightness and outgassing means the object is extraordinarily active, venting far more material than any known comet at that distance from the Sun. Either way, something doesn't add up. Now, here's the frustrating part. We won't know immediately. The data has to be transmitted back to Earth. It has to be processed, analysed, cross-checked. The European Space Agency has already stated they don't expect spectacular images from Mars Express and ExoMars Trace Gas Orbiter. Both spacecraft are designed to look down at Mars, not out into space. At 30 million kilometres, 3I-ATLAS will appear as less than a single pixel in their cameras. They might capture the halo of gas around it, maybe a hint of the tail, but not the nucleus itself. HIRA-C is the real hope, and even then, the timeline is uncertain. Days, maybe weeks, before processed images are released, and in that gap, the object keeps moving. By mid-October, 3I-ATLAS will be too close to the Sun to observe from Earth. The glare will make it invisible. It reaches perihelion, its closest point to the Sun, on October 29th. 1.4 astronomical units, just inside the orbit of Mars, and during that entire period from mid-October through the end of the month, the object will be on the opposite side of the Sun from Earth, hidden, unobservable. That's 26 days, nearly a month, and when it re-emerges in early December, sliding into the pre-dawn sky, we'll finally be able to see it again, check its trajectory, measure its brightness, confirm whether it behaved like a normal comet during perihelion or whether something unexpected happened. But let's come back to today, October 3rd, the Mars moment. Because while the official narrative is focused on resolving the size question, there's another layer to this story. A layer that has less to do with what the cameras will capture and more to do with what the data has already shown. And that's where things start to break. Chapter 2. The 7 Sins Against Nature. Avi Loeb published an article on October 3rd, the same day as the Mars flyby. The timing was deliberate. In it, he laid out what he calls the 7 anomalies of 3I-ATLAS. Not ambiguities, not curiosities, anomalies. Behaviours and characteristics that don't fit the standard model of what an interstellar comet should look like. He divided them into 2 categories. The first category includes 4 anomalies that could potentially be explained or alleviated with better data. The second category contains 3 anomalies that, in his words, will remain puzzling forever, because they're not about missing information. They're about probabilities, about trajectories and timing that suggest something more than random chance. Let's start with the first category, the explainable ones. Anomaly 1, size. We've already touched on this. The diameter of 3I-ATLAS appears to be larger than 5 kilometers, giving it a minimum mass of 33 billion tons. That makes it 1,000 to 1,000,000 times more massive than the previous 2 interstellar objects. The explainability here hinges on whether future observations, like today's Mars flyby, will confirm or revise that number. If the nucleus turns out to be smaller, the anomaly softens. If it's confirmed at 5 kilometers or larger, the statistical problem deepens. Anomaly 2, the jet. Hubble images show a peculiar feature. A forward jet of scattered sunlight 10 times longer than it is wide, pointing directly toward the sun. Most comets display tails that stream away from the sun, driven by solar wind and radiation pressure. But this jet is different. It's oriented in the opposite direction. The explanation offered is that 3I-ATLAS has a powerful outgassing event on its sunward side, releasing material that reflects sunlight before being pushed back. Fine, that's plausible. But here's the catch. The jet appeared early, at distances where most comets are still dormant, and it remained unusually bright and persistent. A weak tail did show up by late August, but only after the object had moved significantly closer to the sun. That delay is odd. It suggests the outgassing dynamics are not behaving like a typical comet. Anomaly 3, chemical composition. This is where things get genuinely strange. Spectroscopic observations from the James Webb Space Telescope and the Very Large Telescope revealed that the plume of gas around 3I-ATLAS contains far more nickel than iron. In normal comets, and even in the previous interstellar comet 2I/Borisov, nickel and iron appear in ratios similar to what we see in the Sun, roughly balanced. But 3I-ATLAS shows extreme nickel dominance. Nickel was detected at every observation epoch. Iron only appeared when the object was closer than 2.64 astronomical units from the Sun, and even then, the nickel-to-iron ratio remained far higher than expected. Why does this matter? Because nickel and iron are refractory metals. They don't sublimate, turn from solid to gas, at the low temperatures found on comets. The surface temperature of 3I-ATLAS, even relatively close to the Sun, is too cold for raw nickel to simply boil off. Something else must be happening. Either there's a parent molecule, a compound containing nickel that breaks down and releases nickel atoms, or the heating mechanism is non-standard. Either way, it's puzzling. And there's more. The gas composition is also unusual. Most comets are water-rich. As they approach the Sun, water ice sublimates and dominates the spectrum. But 3I-ATLAS is carbon dioxide-rich. The ratio of carbon dioxide to water is 8:1. That's among the highest ever recorded. It suggests the object formed in a very cold environment, far colder than the regions where typical solar system comets originate. Anomaly 4. Polarization. This one is technical, but important. When light reflects off dust particles, it becomes polarized. The degree and direction of polarization tells you about the size, shape, and texture of those particles. Every comet and asteroid we've studied falls within a certain range, predictable, consistent. 3I-ATLAS does not. The polarization data came back so far outside the expected range that the research team initially thought there was an error. They repeated the measurements, same result. The only way to explain the numbers is if the dust grains are fundamentally different. Not typical silicate sand, not water ice crystals, something else. Large complex particles, highly porous, almost smoke-like in structure. Now, here's the key. These 4 anomalies are strange, yes, but they're not necessarily fatal to the comet hypothesis. Better data might clarify the size. The jet could be a rare but natural outgassing asymmetry. The nickel could come from an exotic parent molecule we haven't identified yet. The dust could be a product of unusual formation conditions. Uncomfortable, but explainable. Then we get to the second category, the permanent mysteries. Anomaly 5, trajectory alignment. The orbit of 3I-ATLAS is aligned with the ecliptic plane to within 5 degrees. The ecliptic is the flat disk where the planets orbit the Sun. Most interstellar objects, arriving from random directions in the galaxy, should have random inclinations, some steep, some shallow, some retrograde. The probability that an object would arrive on a trajectory so closely aligned with the planetary plane, just by chance, is about 0.2%, 1 in 500. Now, that's not impossible. Rare events happen, but it's the first red flag. Anomaly 6, arrival timing. This is where the probability drops off a cliff. 3I-ATLAS didn't just arrive on a trajectory aligned with the planets. It arrived at a time that allows close encounters with Mars, Venus and Jupiter. Specifically, the object will pass Mars today, October 3rd. It could have reached Venus with minimal course correction in July. And it's positioned for a relatively close pass by Jupiter in March 2026. The probability of an interstellar object randomly arriving on a trajectory, and at a time that allows such encounters, about 0.005%, 1 in 20,000. Think about that for a moment. If you're designing a probe to visit multiple planets in a solar system, you'd want a trajectory that intersects their orbital paths. You'd time your arrival to coincide with their positions. You'd minimize the fuel needed for course adjustments. This is exactly how we design human missions. Voyager, New Horizons, optimize the trajectory, use gravitational assists. 3I-ATLAS looks like it was delivered. Chapter 3, The Impossible Physics. 2 days ago, something changed. On October 1st, 2025, an anonymous post appeared on 4chan, not in a science forum, not on a preprint server, on 4chan's paranormal board, a place more known for internet folklore than legitimate scientific discourse. But this wasn't folklore. The poster claimed to be a PhD researcher working with the European Space Agency. They said they had ongoing access to the combined observational data for 3I-ATLAS, that they were part of a formal working group trying to make sense of this object, and that the group had failed. Quote, "For months I've been part of a formal working group that has tried and failed to reconcile this object's behaviour with any known class of natural celestial body. The official position is that 3I-ATLAS is a uniquely active but otherwise natural comet. This position is no longer tenable, and the silence from leadership on the cognitive dissonance this requires is becoming a serious professional issue for a growing number of us." Now, let me be clear. Anonymous posts on 4chan are not peer-reviewed science. They're not verified. They could be elaborate fiction, roleplay, someone who read the papers and decided to stir up speculation. But here's what makes this different. The level of technical detail is unusual. The frustration in the tone feels genuine, and the claims align disturbingly well with publicly available data, while adding context that hasn't appeared in any official release. So I'm going to walk through what this person said, not as fact, but as a window into what might be happening behind the scenes when scientists look at data that doesn't cooperate. The post begins with outgassing. 3I-ATLAS is venting approximately 150 kilograms of gas and dust per second. This isn't speculation, it's measurable. The James Webb Space Telescope observed it. Spectrometers at the Very Large Telescope confirmed it. The object is hemorrhaging material. Carbon dioxide, water ice, dust grains constantly, violently. And according to this researcher, it does nothing. Quote, "It feels like a mistake in the data until you've checked it 100 times with all the available instruments. The object is venting about 150 kilograms of gas and dust every single second. We see it, yet it does nothing. is like watching a howitzer fire a shell with absolutely zero recoil or smoke or bang. It's a constant, violent event with no consequences, and that is a disgusting violation of basic physics. Let me explain why that's a problem. When a comet releases gas, it experiences thrust. Newton's third law. For every action, there's an equal and opposite reaction. The gas jets away from the surface. The comet recoils. It's tiny, yes, but measurable over time. This creates what astronomers call non-gravitational acceleration, a slight deviation from a purely gravitational trajectory. Every active comet shows this. Halley's Comet, Comet Hale-Bopp, 2I/Borisov, the previous interstellar visitor. All of them displayed measurable non-gravitational acceleration as they outgassed near the Sun. 3I-ATLAS shows almost none. There's a paper, published in September, authored by Richard Cloete, Avi Loeb and Peter Veers. They analysed 4,022 positional observations from 227 observatories worldwide collected between May and September. They calculated the object's trajectory with extreme precision. Then they looked for deviations, residuals, any sign that the outgassing was pushing the object off course. The upper limit they found was 0.028 arcseconds across months of observation. That corresponds to a non-gravitational acceleration of less than 15 meters per day squared. For an object venting 150 kilograms per second, that's impossibly small, almost zero. The only way the physics works, according to the poster, is if the object is far more massive than it appears. Quote, "The only way the physics works is if the object has the mass of a small moon, crammed into a space no more than 2 to 3 kilometers across. The lower models give us a limit of 33 billion tons, which just creates a second, worse problem. Finding a mountain on an interstellar trajectory is statistically impossible. Think about what that means. If 3I-ATLAS has the mass to resist the recoil from venting 150 kilograms per second, it must be incredibly dense. Far denser than ice, denser than rock, approaching the density of iron. A 3-kilometer sphere of solid nickel iron would have roughly that mass. But this isn't a metallic asteroid. It has a coma, a tail. It's outgassing like a comet, so the mass has to be there but somehow compatible with volatile ices on the surface." The poster continues, quote, "Our surveys have only just started. To find an object this massive this soon means the galaxy isn't just dotted with debris, it's swarming with them. The models are wrong by a factor of 10,000. Our entire picture of what gets ejected from solar systems is fundamentally, grotesquely flawed. Or this object isn't debris at all, and that is the quiet and terrifying conclusion we are being discouraged from discussing." Pause here, let that sink in. If the mass estimate is correct, 33 billion tons or more, then the statistical models break. Because large interstellar objects should be rare, exponentially rarer than small ones. For every mountain-sized rock, there should be millions of pebbles. But we've detected 3 interstellar objects so far. A small pancake-shaped thing, a relatively normal comet, and now something 1,000 times more massive. The sequence is inverted. Either we've gotten incredibly, impossibly lucky, or the galaxy contains far more massive interstellar objects than we thought, orders of magnitude more, which means our understanding of planetary system formation, of how material gets ejected into interstellar space, is wrong at a fundamental level. Or the third option, this object isn't debris. But it gets worse. According to the post, the chemistry doesn't make sense either. Quote, "You look at what's actually in the gas, it gets worse. We're seeing pure atomic nickel steaming off. It's happening at temperatures where it should be frozen solid. This isn't gradual, like ice turning to vapor, it's a switch. The nickel production is insanely sensitive to sunlight. A tiny change in heat and it just shuts off. There's only one way you get that, a breakdown of a parent molecule. The only option is nickel tetracarbonyl, something we use in industrial refining. It explains everything, especially why there's no iron, but it's not a naturally occurring compound. What the hell is a synthetic chemical doing on a rock which we think has been in space for billions of years? Nickel tetracarbonyl. Let's talk about that for a moment. It's a chemical compound. Formula, nickel bonded to 4 carbon monoxide groups. At room temperature it's a liquid. Colourless. Highly toxic. Highly volatile. It was discovered in 1890 by a chemist named Ludwig Mond. We use it industrially in a process called the Mond process. to purify nickel metal. You take impure nickel, expose it to carbon monoxide gas under specific conditions, and nickel tetracarbonyl forms. Then you heat it and the compound breaks down, depositing pure nickel. It's synthetic, created in labs and refineries. It doesn't occur naturally on Earth. And according to this researcher, it's the only compound that explains the nickel emission profile from 3I-ATLAS, the temperature sensitivity, the on-off behaviour, the absence of iron. But if nickel tetracarbonyl is present on a comet that's supposedly billions of years old, formed in some distant protoplanetary disk, how did it get there? Natural processes don't make nickel tetracarbonyl. It requires specific conditions, high-pressure carbon monoxide interacting with metallic nickel, and even if those conditions existed somewhere in the early solar system, the compound is unstable. It breaks down. It wouldn't survive billions of years in interstellar space. Unless it's being actively produced, which raises an even stranger question. Produced by what? The poster then shifts to the dust. Quote, "And the dust it's shedding is just as messed up. We measure how light reflects off it. Its polarization. Tells you about the texture of the particles. Every comet, every asteroid, they all fall within a certain range. This thing's data comes back so far off what's expected, our director insisted we were messing up for the best part of a week until we repeated the result. The only way to get these numbers is if the dust grains are something else entirely. Not sand, not ice. Large, incredibly complex particles, black and porous as smoke, is not natural dust. It's a manufactured material. The chemistry is wrong, the physics is wrong. It's a perfectly self-consistent system of wrongness, as though its whole purpose is to make us doubt ourselves. Manufactured material. That's the phrase they used. Now, we do have public data on the polarization. A paper was published in September analysing optical observations from multiple telescopes. The polarization degree for 3I-ATLAS was measured at minus 2.1% at a phase angle of about 90 degrees. Negative polarization at that angle is extremely rare. It means the light is polarized perpendicular to the scattering plane, which only happens with very specific particle properties, highly irregular shapes, complex internal structures. The paper noted this was unusual, but stopped short of calling it impossible. This alleged insider is saying the internal discussions went further, that the measurements were so far outside normal parameters, they assumed instrument error, until they repeated the observations and got the same result. If the dust grains are large, complex and porous, that suggests a formation mechanism unlike anything we see in normal comets. Comets shed dust when ice sublimates and lifts particles off the surface. The dust is typically small, micron-sized, relatively simple silicate or carbonaceous grains. But large, porous particles, that's different. That's almost like, the poster says, smoke, aerosol particles, finely divided material with a huge surface area to volume ratio. That's the kind of dust you get from combustion, or from industrial processes, or from something breaking down a solid material into an ultrafine powder, not from ice sublimating off a rock. The post continues with rotation, or rather, the lack of it. Quote, "Hubble and Webb see a feature that shouldn't exist. Faint, greasy smear of a tail pointing straight at the sun. Supposedly, a massive carbon dioxide jet is firing from its sun-facing side, powerful enough to lift heavy water ice grains that sunlight can't easily push away. A violent directional engine. Okay, fine. But it isn't rotating. We've stared at it for days on end. Its brightness doesn't change, not by a fraction of a percent. It's a dead flat line. A jet that powerful on a rotating body would create a pulse, a flicker, a rhythm. We see absolute, perfect, unwavering stillness. The explanation for the tail requires a violent directional event. The observation of its light requires a perfectly uniform cloud. You can't have both. One is a lie. Either the model for the tail is bullshit, or that cloud isn't natural. This is subtle, but it's important. If 3I-ATLAS is rotating, and if it has a jet firing from one side, we should see periodic brightness variations, as the jet rotates into and out of view. As different parts of the nucleus reflect sunlight toward us. This is standard behavior for comets. Brightness curves, light curves, they flicker. 3I-ATLAS doesn't. According to this researcher, the brightness is constant, stable, dead flat. That implies one of two things. Either the object isn't rotating at all, which is nearly impossible for something travelling through space for billions of years. Every collision, every gravitational interaction imparts angular momentum, or the brightness is constant because the outgassing is perfectly symmetric, isotropic, happening equally in all directions all the time. But a symmetric outgassing pattern doesn't explain the forward tail. The tail points toward the sun. That requires directionality, a jet, an asymmetry. So you have two incompatible observations, a tail that demands a jet, a brightness curve that demands symmetry. Both can't be true, unless the cloud of dust and gas surrounding the object is somehow decoupled from its rotation, or unless the object is regulating its surface activity in a way that maintains constant brightness regardless of orientation. Neither of those options is natural. Then there's the thermal problem. Quote, then there's the heat. The thing is cold. It's absorbing gigawatts of raw solar energy, enough to power a small city. We calculate the energy budget, and there's a massive surplus. That heat has to go somewhere. It should be driving off enormous plumes of water vapour. But the water isn't there. It's like pointing a blowtorch at an ice cube and watching it refuse to melt. The object has found a way to either dispose of or regulate an enormous thermal load to keep its surface locked at a specific low temperature. Energy balance. One of the most basic principles in physics. Energy in equals energy out plus or minus whatever gets stored. For a comet approaching the sun, energy in is sunlight. Energy out is thermal radiation and the latent heat of sublimation. As ice turns to gas, it absorbs energy. That's how comets stay cool. The sublimation process is a heat sink. But if 3I-ATLAS is absorbing gigawatts of solar power and not releasing proportional amounts of water vapour, where is the energy going? According to this researcher, the thermal models don't balance. There's a surplus. Heat that should be driving activity but isn't showing up in the expected emissions. One possibility is that the surface is highly reflective, albedo. If most of the sunlight is reflected rather than absorbed, the energy input is lower. But then, the object should be brighter than it appears. Another possibility is that the heat is being conducted into the interior, stored in the bulk mass. But that requires a very high thermal conductivity, unusual for icy material. Or, the heat is being radiated away in wavelengths we're not measuring, infrared, far infrared. Or the object is actively regulating its surface temperature, which sounds absurd, but that's what the data seems to suggest. And finally, the trajectory. Quote, and that's before you even look at the path it took to get here. Its trajectory is a statistical joke. It's a perfect low angular momentum orbit, the kind that guarantees a close pass. The physicists who model this stuff are blunt. There is no known natural process that filters massive objects onto these trajectories. It wasn't just a random encounter. For all intents and purposes, this thing was delivered from the darkness. We've already talked about the ecliptic alignment, the planetary encounter timing, the probabilities, but this adds another layer, low angular momentum. That means the orbit isn't just aligned with the planets, it's moving relatively slowly compared to typical interstellar speeds. Most interstellar objects zip through the solar system at tens of kilometers per second. Oumuamua was travelling at 26 kilometers per second relative to the Sun. Fast. 3I-ATLAS is moving at about 60 kilometers per second in interstellar space. But when you account for the Sun's gravity, its close approach speed is lower, manageable, almost like it was designed to linger. The post ends with a unifying statement. Quote, you don't get it. None of these are separate problems. They're all symptoms of a single underlying sickness. A jet powerful enough to make the tail would make the object flicker. It doesn't. A body that massive should be dead. It isn't. The sun's heat should be boiling it alive. It feels nothing. Each paradox is a wall. And we're all standing here staring at the walls, refusing to see the shape of the room. This isn't a failure of our models. This is a glimpse of the machinery running underneath them. And it's wrong. A glimpse of the machinery running underneath. That phrase is haunting, because it suggests the anomalies aren't bugs, they're features, that the object isn't broken. It's operating according to rules we don't understand. And then, the researcher offers an explanation, one that sounds like science fiction, but according to them, it's the only physics that makes the data coherent. Chapter 4. The Chemical Nightmare. Let's talk about what's actually streaming off this object. because the chemistry isn't just unusual. According to the leaked post, it's impossible. The nickel story starts with temperature. When the Very Large Telescope pointed its UV spectrograph at 3I-ATLAS between August and September, it detected emission lines from nickel atoms. Not nickel compounds, pure atomic nickel, glowing in the spectrum, present at every observation epoch. Here's the problem. Nickel is a refractory metal. Its melting point is 1,455 degrees Celsius. Its boiling point is 2,913 degrees Celsius. At the distance 3I-ATLAS was orbiting, between 3.1 and 2.1 astronomical units from the Sun, surface temperatures would be somewhere between -100 and -50 degrees Celsius, far, far below the point where solid nickel could sublimate into atomic vapor. Yet there it is, streaming off in measurable quantities. The official explanation in the published paper is cautious. Quote from the researchers: "The presence of nickel and iron atoms in cometary coma is extremely puzzling. At the distances at which comets are observed, the temperature is far too low to vaporize silicate, sulfide, and metallic grains that contain nickel and iron atoms." They suggest a parent molecule, some organic compound containing nickel that breaks down when exposed to sunlight, releasing nickel atoms. But they don't identify what that molecule might be, because in nature, nickel doesn't form many volatile compounds. It's chemically stable, it likes staying solid. The alleged insider goes further. They name the molecule nickel tetracarbonyl, and they explain why that's deeply troubling. Nickel tetracarbonyl is what chemists call an organometallic compound. One nickel atom bonded to 4 carbon monoxide groups. It's a liquid at room temperature, highly volatile. It boils at 43 degrees Celsius, and crucially, is photosensitive. Expose it to ultraviolet light, the kind the sun emits in abundance, and it breaks down. The carbon monoxide groups detach. Pure nickel atoms are left behind. This would perfectly explain the observations. Nickel tetracarbonyl on the surface, warmed slightly by sunlight, begins to sublimate. The vapor drifts into space. Ultraviolet photons hit it. The molecule decomposes. Atomic nickel appears in the spectrum. And because the breakdown is light-driven, not just heat-driven, the nickel production would be extremely sensitive to solar illumination. A tiny change in distance, a small shift in angle, and the rate changes dramatically. That matches what the VLT data shows. The nickel production rate increases steeply as 3I-ATLAS approaches the Sun. To the 9th power, according to the measurements. A steep, sharp dependence. Exactly what you'd expect from a photodissociation process. So the chemistry fits. But here's the issue. Nickel tetracarbonyl doesn't occur in nature. It's synthetic. We make it in industrial settings using the MOND process. You take metallic nickel, expose it to carbon monoxide gas at high pressure and moderate temperature, and nickel tetracarbonyl forms. Then you heat it in a different chamber, the compound breaks down, and you're left with purified nickel. It's a refining technique. Patented in 1890. How does a synthetic industrial chemical end up on an interstellar comet? One option. Maybe the conditions for forming nickel tetracarbonyl exist somewhere in space. Protoplanetary disks are rich in carbon monoxide. If metallic nickel grains are present, and if the pressure and temperature are right, maybe the compound forms naturally. Not impossible, but unlikely. And even if it forms, nickel tetracarbonyl is unstable. It decomposes over time, especially when exposed to radiation. An object travelling through interstellar space for billions of years, bathed in cosmic rays, shouldn't have intact nickel tetracarbonyl on its surface, unless it's being produced, actively, continuously, by some internal process. That's the suggestion the insider makes, that 3I-ATLAS isn't carrying ancient nickel tetracarbonyl from its formation, it's generating it, as a byproduct of whatever is happening inside. Then there's the iron, or rather the lack of it. In normal comets, nickel and iron appear together. They're both present in similar ratios to what we see in the Sun. Roughly 1 nickel atom for every 20 iron atoms. That's the cosmic abundance. It's what you expect from material that formed in a protoplanetary disk around a star. 3I-ATLAS shows extreme nickel dominance. Iron only appeared in the spectrum when the object was closer than 2.64 astronomical units. Even then, the nickel-to-iron ratio remained far higher than normal, an order of magnitude off. Why? If both metals are present in the comet's composition, why does nickel sublimate freely while iron stays locked up? The insider's explanation ties back to nickel tetracarbonyl. Iron doesn't form a comparable volatile compound. Iron pentacarbonyl exists, but it's less stable, less likely to form under the same conditions. If the outgassing process preferentially produces nickel tetracarbonyl, you'd see nickel without iron. The chemistry is selective. But again, that requires an active process, not just ice sublimating and dragging metal grains along, something chemically sophisticated. Now let's talk about the dust, because the polarization data is where things get truly strange. When light scatters off dust particles, it becomes polarized. The degree and angle of polarization depend on the size, shape, and composition of the particles. Astronomers use this as a diagnostic tool. You measure the polarization, compare it to models, and you can infer what kind of dust you're looking at. Every comet and asteroid ever studied falls within a predictable range. Silicate dust, ice grains, carbonaceous particles, they all produce similar polarization signatures. Small variations, sure, but within bounds. 3I-ATLAS is off the charts. According to the public data, the polarization at a 90-degree phase angle is minus 2.1%. Negative polarization at that geometry is rare. Very rare. It typically requires particles with extremely irregular shapes or complex internal structures. The leaked post describes the reaction when the data first came back. Quote, "Our director insisted we were messing up for the best part of a week until we repeated the result. They checked the instruments, recalibrated, observed again, same answer. The only way to explain the numbers, according to the post, is if the dust grains are fundamentally different. Not natural dust. Not the kind of particles that form when ice sublimates and lifts rocky material off a comet's surface. Quote, large, incredibly complex particles, black and porous as smoke. Think about what that means. Typical comet dust is small, micron scale, a few micrometers across, simple grains, but large complex particles suggest something else. Aggregates, fluffy structures with lots of empty space inside, high surface area, low density, almost like soot or aerosol. That's the kind of dust you get from combustion or from chemical vapor deposition. Processes that build particles atom by atom, layer by layer, creating intricate structures. Not processes that happen naturally on a frozen rock. And black. Most comet dust is relatively bright. It reflects a fair amount of sunlight. That's why comets are visible. But black dust absorbs light. It's thermally efficient. It heats up quickly. If the dust around 3I-ATLAS is black and porous, it would absorb solar energy, warm up, and radiate in the infrared. Which brings us back to the thermal problem. Where is all that absorbed energy going? The post frames the chemical weirdness as part of a larger pattern. Quote, "The chemistry is wrong, the physics is wrong. It's a perfectly self-consistent system of wrongness, as though its whole purpose is to make us doubt ourselves." Self-consistent. That's the key phrase. Each anomaly taken alone could be explained away. Unusual, but possible. But together they form a system. Coherent picture. Just not a picture that fits the natural comet hypothesis. It's like looking at a machine where every part is slightly off spec, but the machine still runs. You start wondering if the specs are wrong, or if the machine was built to different standards. Now, I want to be clear. The official scientific position, the one held by most astronomers, is that 3I-ATLAS is a comet. An unusual comet, yes, with properties that push the boundaries of what we've seen before, but still natural, still explainable within the framework of planetary science. NASA has said this explicitly. Tom Statler, NASA's lead scientist for solar system small bodies, told reporters, quote, "It looks like a comet. It does comet things. It very, very strongly resembles, in just about every way, the comets that we know." And he's not wrong. 3I-ATLAS has a coma. It has a tail. It's outgassing as it approaches the sun. Those are comet behaviors. But the details, the chemistry, the dust, the thermal balance, those are where the questions live. The insider's post doesn't claim certainty. They're not saying this is definitely alien, or this is definitely artificial. What they're saying is simpler, and in some ways more disturbing. Quote, "For months I've been part of a formal working group that has tried and failed to reconcile this object's behaviour with any known class of natural celestial body. failed. Not, we're still working on it. Not, we need more data. Failed. That's the word they used. And if this leak is genuine, if it reflects real internal discussions within the European Space Agency's working group, then there are scientists looking at this data who are privately admitting they don't have an answer. Which raises a question. If the standard explanations don't work, what does? That's where the post takes a turn, into territory that sounds like theoretical physics or science fiction, depending on how generous you want to be. Chapter 5. The rotation that doesn't exist. Every object in space rotates. It's unavoidable. Collisions impart spin, gravitational interactions add angular momentum. Even the gentlest cosmic encounter, billions of years ago, leaves an object tumbling through their void. Rotation is the default state. So when astronomers observe a new comet or asteroid, one of the first things they look for is the rotation period. How fast is it spinning? They watch the brightness over time. As the object rotates, different parts of its surface face the observer. Dark spots, bright spots, irregular shapes. The brightness fluctuates, sometimes subtly, sometimes dramatically, but it fluctuates. This is called a light curve. Plot brightness versus time, and you get a periodic wave. The period tells you the rotation rate. The amplitude tells you how irregular the shape is. It's one of the most basic measurements in observational astronomy. 3I-ATLAS doesn't have one. According to the leaked post, the object has been monitored continuously. Hubble watched it. Webb watched it. Ground-based observatories tracked it night after night, and the brightness stays constant. Quote, "We've stared at it for days on end. Its brightness doesn't change, not by a fraction of a percent. It's a dead flat line. Dead flat. No variation. No flicker. No periodic signal. That's wrong. Not just unusual. Wrong. Even a perfectly spherical object, if it has surface features, any variation in albedo, any patches darker or lighter than average, will show brightness variations as it rotates. And comets are never perfectly spherical. They're irregular, lumpy, cratered. Outgassing jets create bright spots. Dust accumulation creates dark spots. Rotation should create a rhythm. But 3I-ATLAS doesn't flicker. Now there's one scenario where you might not see rotation. If the object is rotating very slowly, if the period is weeks or months long, you might not detect a full cycle during limited observation windows. But even then, you'd expect to see gradual brightness changes as the object slowly turns. A drift, a trend, something. The post describes the brightness as unwavering, stable, locked. So either 3I-ATLAS isn't rotating at all, which is physically implausible for an object travelling through space for billions of years, or it's rotating but the brightness is somehow independent of rotation, which requires an explanation. Here's where it gets complicated. Hubble and Webb both observed a feature, a forward tail, a plume of material pointing toward the sun. The natural explanation is a jet, a localized outgassing event on the sunward face of the comet, where solar heating is strongest. Jets are common on comets. Sublimating ice creates pressure. Gas escapes through cracks or vents. Dust gets carried along. You get a directional plume. But jets are asymmetric. By definition, they fire from one location in one direction. If the object is rotating, the jet rotates with it. Sometimes it points toward you, sometimes away, sometimes sideways. The amount of reflected sunlight changes. You get a pulse, a flicker, a brightness variation tied to the rotation period. 3I-ATLAS has a feature that looks like a jet, but no brightness variation. Those two observations are incompatible. The post frames it bluntly. Quote, "A jet powerful enough to make the tail would make the object flicker. It doesn't. The explanation for the tail requires a violent directional event. The observation of its light requires a perfectly uniform cloud. You can't have both. One is a lie. Either the model for the tail is bullshit, or that cloud isn't natural. Let's unpack that. If the tail is real, driven by a jet, the jet should be visible as a periodic brightness change. But the brightness doesn't change. So either the tail isn't a jet, it's something else. Or the brightness is somehow decoupled from the jet. One possibility. The outgassing is isotropic, perfectly symmetric, happening equally in all directions all the time. Like a sphere slowly evaporating, no jets, no asymmetry. That would explain the constant brightness, but it doesn't explain the forward tail. Isotropic outgassing produces a symmetric coma and a tail pushed back by solar wind, not a forward-pointing plume. Another possibility. The dust cloud surrounding the object is so thick, so optically dense, that it smooths out any brightness variations. The jet might be firing, but it's hidden inside a fog. What we see is the outer envelope which appears uniform. That could work, but it requires a massive dust production rate, and the spectroscopic data shows the coma is relatively thin, not optically thick. A third possibility. The object is regulating its brightness, actively, somehow maintaining a constant reflective surface regardless of rotation or jet activity. That sounds absurd, but it's the only scenario that reconciles both observations without discarding one as error. The insider suggests this points to something deeper, that the rotation issue isn't a separate problem. It's part of the same system of wrongness, the same underlying machinery that makes the outgassing recoilless, that produces synthetic chemistry, that sheds manufactured dust. And that machinery, according to the Post, is internal, not solar-powered, not driven by external heating. Which brings us to the next piece, the thermal ghost. 3I-ATLAS is absorbing gigawatts of solar energy. This isn't an estimate, it's calculable. You take the object's cross-sectional area, multiply by the solar flux at its distance, and you get the power input. For an object 5 kilometers across at roughly 2 astronomical units from the Sun, the absorbed power is on the order of several gigawatts, enough to run a small city. That energy has to go somewhere. In a typical comet, it goes into sublimating ice, water ice, carbon dioxide ice, other volatiles. The phase change from solid to gas absorbs energy, lots of it. That's how comets stay cool. The sublimation process is a heat sink. Energy in, gas out. But here's the problem. The amount of energy being absorbed doesn't match the amount of material being released. According to the leaked Post, the thermal models don't balance. Quote, "We calculate the energy budget, and there's a massive surplus. That heat has to go somewhere. It should be driving off enormous plumes of water vapour, but the water isn't there." The Webb telescope measured the gas composition, mostly carbon dioxide, some carbon monoxide. Water is present, but in far smaller quantities than expected. The ratio of carbon dioxide to water is 8:1. That's extremely high. Most comets are water-dominated. Water is the primary volatile. It's what drives cometary activity. But if 3I-ATLAS is absorbing gigawatts and not releasing corresponding amounts of water, where is the energy going? One option. It's being radiated away. Objects emit thermal radiation. The hotter they are, the more they radiate. If 3I-ATLAS has a high emissivity, if its surface is efficient at radiating heat, it could dump energy into space without needing to sublimate large amounts of ice. But there's a problem. The spectroscopic data suggests the surface temperature is cold, very cold. Far colder than it should be for an object absorbing that much sunlight. Quote from the Post, "The thing is cold. It's like pointing a blowtorch at an ice cube and watching it refuse to melt." So the object is absorbing gigawatts, not releasing water and staying cold. That energy is disappearing. Into what? Into where? The Post suggests the object has found a way to regulate its thermal load. Quote, "The object has found a way to either dispose of or regulate an enormous thermal load to keep its surface locked at a specific low temperature." Regulate. That word again implies control, implies a system. Not passive thermal physics, active management. If the surface temperature is being maintained artificially low, that requires either a very efficient cooling mechanism or an internal heat sink, something that absorbs energy and stores it, or transforms it without raising the surface temperature. What could do that? In nature? Not much, certainly not on a comet. The insider's conclusion. Quote, "The gigawatts from the Sun are a trivial external variable to a monstrous 3 billion-year-old object with its own power source. It radiates solar energy away passively, like any inert rock would, because the Sun is not part of its life cycle. Its own power source, an internal engine, something generating energy from within, independent of solar heating. And if that's true, then the thermal regulation isn't a mystery. It's a consequence. The object doesn't need the Sun. It's indifferent to it." Which raises the most disturbing question of all. If 3I-ATLAS has an internal power source, what is it? Chapter 6. the cue ball hypothesis. The leaked post takes a turn here, into physics that sounds like science fiction, but according to the researcher, it's the only framework that makes the data coherent. Quote, "It is a macroscopic quantum object, a stable, massive particle left over from the first microseconds of the Big Bang, a bubble of a different set of physical laws that has managed to survive, cloaked in a skin of our reality. The name for this engine in theoretical physics is a non-topological soliton, or cue ball. This isn't a theory. It is the only known physics that makes the data coherent. A cue ball. Let's talk about what that means. In the very early universe, immediately after the Big Bang, conditions were extreme. Temperatures and densities beyond anything we can replicate. At those energies, the fundamental forces behaved differently. Particles that are distinct today, electrons, quarks, photons, were unified in a hot plasma. As the universe expanded and cooled, it underwent phase transitions, symmetries broke, forces separated, matter condensed into the forms we recognize. But phase transitions don't always happen uniformly. Just like water freezing into ice can create pockets and bubbles, the early universe might have created defects. Regions where the phase transition didn't complete cleanly. Pockets where the old unified state persisted, trapped, stable. These defects have names: cosmic strings, monopoles, domain walls, and cue balls. A cue ball is a non-topological soliton. That's jargon. Let me translate. A soliton is a self-sustaining wave, a lump of energy that holds its shape because of a balance between dispersive forces trying to spread it out and non-linear effects pulling it together. Non-topological means it's not held together by the geometry of space, like a knot. It's held together by a conserved quantity, a charge. The Q stands for charge. In certain theoretical models, particularly supersymmetric extensions of the standard model, cue balls can form. They're made of scalar fields, fields with spin zero. These fields have potential energy, and in the right configuration they can create a stable, massive object. A bubble where the field inside has a different value than outside. The bubble doesn't collapse because the field configuration is energetically favourable. It's a local minimum in the potential energy landscape. The key property: a cue ball is its own energy source. The field inside is decaying, very slowly, releasing energy over billions of years. That energy manifests as particles, radiation, heat. The cue ball gradually loses mass, but the process is so slow that a cue ball formed in the early universe could still exist today. Now, this is speculative physics. Cue balls have never been observed. They're predicted by certain theories, but those theories aren't confirmed. Most physicists consider them interesting hypotheticals, objects that might exist in the universe but probably don't. Except, the insider is claiming 3I-ATLAS fits the profile. Perfectly. Let's go through the logic. If 3I-ATLAS is a cue ball, what would we expect to see? First, enormous mass in a small volume. Cue balls are dense. The field inside is concentrated. A 3-kilometer cue ball could easily have the mass of a small moon, 33 billion tons. That matches the minimum mass estimate derived from the lack of non-gravitational acceleration. Second, isotropic outgassing. The cue ball's decay is happening inside, at the core. Energy is released uniformly in all directions. It heats the surrounding material, a mantle of accumulated ice and dust from the inside out. That ice sublimates, symmetrically. No jets, no directional thrust. The outgassing is perfectly balanced, no net recoil. That explains the howitzer with no kickback, the violent outgassing with zero consequence. The decay engine inside produces the gas. The gas escapes in all directions equally. Newton's third law is satisfied. Action and reaction cancel out. Third, constant brightness. If the outgassing is isotropic, the cloud of dust and gas surrounding the cue ball is spherically symmetric. Rotation doesn't matter. The object looks the same from every angle. The brightness doesn't flicker because there's no asymmetry to rotate. Fourth, exotic chemistry. A cue ball's decay doesn't follow normal thermodynamics. It's a particle physics process, high energy, capable of creating unusual compounds. The slow burn reactor, as the post calls it, operates at constant, low temperature. But it's not a thermal furnace. It's a quantum decay event. Over billions of years, this produces byproducts: complex molecules, metallic carbonyls, manufactured dust, the exhaust of an ancient engine. Fifth, thermal indifference. The cue ball doesn't care about the sun. Its internal energy source dwarfs solar heating. The surface temperature is regulated not by absorbing and re-radiating sunlight, but by the steady output from the core. The gigawatts from the sun are, quote, a trivial external variable. Sixth, the trajectory. If cue balls are common, if they are a component of dark matter, then the galaxy is full of them. Not rare, not anomalous, everywhere. 3I-ATLAS isn't debris ejected from a distant star, it's part of the fundamental population, a relic from the Big Bang. That explains why we found something this massive this quickly. We're not looking at ejected planetary material, we're looking at dark matter itself. The Post frames this as a revelation. Quote, the cue ball is the mass, its engine is its own decay. The lack of recoil is no longer a paradox, it's a defining feature. The outgassing isn't a jet, it is an isotropic ablation, a perfectly spherically symmetric outflow of matter as the core's energy boils its mantle from the inside out. There is no net thrust. It moves without consequence because the event is happening inside a perfectly balanced system. And then, quote, this is not a matter of belief. This is the only known physics that makes the data coherent. Once you look at it, the entire system of wrongness snaps into a logical, horrifying picture. Horrifying, that's the word used, not intriguing and not surprising. Horrifying. Why? Because if 3I-ATLAS is a cue ball, then dark matter is an invisible, inert stuff scattered through space. It's active, it's massive, and it's everywhere. The galaxy isn't dotted with a few interstellar rocks, it's swarming with ancient, massive objects. Each one a relic from the Big Bang, each one slowly decaying, each one capable of wandering into a solar system and doing what exactly? Nothing, or something worse. But here's the critical part. The cue ball hypothesis is testable. The Post ends with predictions, specific falsifiable claims. Quote, screen cap this. First prediction, activity independent of solar distance. A normal comet's behavior is driven by solar heating. As it moves away from the sun, the activity drops. The outgassing slows, the brightness fades. This is universal. Every comet we've observed follows this pattern. But if 3I-ATLAS has an internal engine, its activity won't follow that pattern. As it recedes into the outer solar system past 3 astronomical units, past 4, the brightness and mass loss rate should remain impossibly high. It will violate the thermodynamic expectation for a passive cooling body. That's testable. We can watch. When the object re-emerges in December after passing behind the sun, we'll have months to observe it as it moves outward. If it stays bright, if the outgassing continues unabated, that's a smoking gun. Comets don't do that. Second prediction, high energy emission. The cue ball's decay is a particle physics event, 73 megawatts of energy, according to the Post's estimate. That energy doesn't just vanish. It produces particles, high energy particles, gamma rays, X-rays, a non-thermal high energy signature that should be detectable. Quote, point a gamma ray telescope at it. If you detect a signal that is not attributable to solar-wind interaction, you are not seeing a comet. You're hearing the heartbeat of an object that doesn't follow the rules of physics. That's also testable. Gamma ray observatories exist. Fermi, integral. If there's a high energy source at the location of 3I-ATLAS, we can find it. No comet emits gamma rays from internal processes. Only extreme astrophysical objects do. Pulsars, black holes, supernova remnants. Or, if the hypothesis is correct, cue balls. Now, let me be absolutely clear. This is not mainstream science. Cue balls are theoretical, speculative. Most astrophysicists would dismiss this hypothesis outright. It's exotic. It requires accepting that dark matter takes a form we've never detected, that the early universe produced stable, macroscopic quantum objects, that one of those objects happens to be passing through our solar system right now. The simpler explanation is that 3I-ATLAS is just a weird comet. Unusual chemistry, unusual dust, maybe a binary nucleus or some internal structure we don't fully understand yet, but still natural, still explicable within conventional planetary science. That's the position most scientists hold, and they might be right. But if the leaked post is genuine, if there really is a European Space Agency working group struggling to make the data fit, then the cue ball hypothesis is being discussed, quietly, behind closed doors, not as the answer, but as the only alternative that doesn't require ignoring half the observations. And if the predictions hold, If 3I-ATLAS stays bright as it leaves, if gamma rays are detected, then the conversation changes. Fast. Chapter 7. The Hidden Maneuver Window. 26 days from now, 3I-ATLAS will do something that should make everyone nervous. It will disappear. Not literally. The object will still be there, still moving on its trajectory, but from Earth's perspective it will be invisible, hidden behind the sun, swallowed by the glare of our own star. This happens on October 24th. The object reaches solar conjunction. Earth, Sun, and 3I-ATLAS form a straight line, with the Sun in the middle. From that point until early December we cannot see it, cannot track it, cannot measure its position or brightness or spectrum. For nearly 6 weeks the object vanishes from view. And on October 29th, right in the middle of that blackout period, 3I-ATLAS reaches perihelion, its closest approach to the Sun, 1.4 astronomical units, just inside the orbit of Mars, the moment when solar heating is strongest, when a normal comet would be most active, when outgassing would peak. We won't see any of it. This timing has not gone unnoticed. Avi Loeb wrote about it explicitly in his October 3rd article. Quote, "At its perihelion on October 29th, 2025, when it reaches 1.35 astronomical units from the Sun, 3I-ATLAS will be totally obscured from the Earth by the Sun. If we assume this obscuration occurs within a solar elongation of 30 degrees, then it is straightforward to calculate the likelihood of this alignment with the Sun and Earth as roughly 7%. 7%. Not impossible, but not random chance either. 1 in 14. And here's where it gets uncomfortable. If 3I-ATLAS were a spacecraft, if it had propulsion, if it could maneuver, perihelion would be the optimal moment to do so, specifically to perform what's called a reverse Oberth maneuver. Let me explain. The Oberth effect is a principle in orbital mechanics. When you fire a rocket engine, the change in kinetic energy depends not just on the thrust, but on your current velocity. Fire the engine when you're moving fast, and you get more bang for your buck. The kinetic energy gain is larger. Spacecraft use this all the time. When you want to escape a planet or star, you apply thrust at periapsis, the point of closest approach, where your orbital velocity is highest. That's a standard Oberth maneuver. Maximum efficiency. A reverse Oberth maneuver is the opposite. You're moving fast on a hyperbolic trajectory, heading out of the system. But you want to stay. You want to become gravitationally bound, so you fire your engines at perihelion when you're moving fastest, and you slow down. The velocity reduction is most efficient at that point. You dump energy and the trajectory changes from hyperbolic to elliptical. Instead of escaping, you stay captured. If 3I-ATLAS wanted to remain in the solar system, October 29th would be the moment to break, and it would happen behind the Sun, hidden from Earth, unobservable. Loeb frames this carefully. He's not claiming this will happen. He's pointing out that the geometry is convenient. Quote from his article, "This could be intentional to avoid detailed observations from Earth-based telescopes when the object is brightest or when gadgets are sent to Earth from that hidden vantage point. The optimal point for a reverse solar Oberth maneuver to become bound to the Sun is at perihelion. It is this optimal breaking point for 3I-ATLAS that is obscured from our view by the Sun. Gadgets. That's the word he used. Small probes, released from the main object, taking advantage of the retrograde orbit and the close planetary encounters to reach Mars, Venus, or Jupiter with minimal fuel requirements. The calculations exist. In Loeb's July paper with Adam Hibbard and Adam Crowell, they worked out the delta-v requirements. Delta-v is the change in velocity needed to reach a target. For 3I-ATLAS to send a probe to Mars in early October, the required delta-v is less than 5 kilometers per second. That's comparable to an intercontinental ballistic missile, achievable with chemical propulsion. Venus? Same story, less than 5 kilometers per second until July. Jupiter? Less than 5 through November. Earth requires more, always above 5 kilometers per second, higher energy cost, which, if you were designing a reconnaissance mission, might explain why Earth gets skipped in the initial pass. Visit the other planets first, gather data, then decide if Earth is worth the fuel. Again, this is hypothetical. Loeb isn't saying this is happening, he's saying it's possible, that the trajectory and timing allow for it. But here's the key, we won't know until December. When 3I-ATLAS re-emerges from behind the Sun in early December, it will appear in the pre-dawn sky, low on the eastern horizon, faint but observable, and the first thing astronomers will do is measure its position, calculate its trajectory, check if anything changed. If the orbit is identical to predictions, if the object is exactly where it should be based on a purely gravitational path, then nothing happened. It passed perihelion, outgassed, and continued on its way. A comet. Unusual, but natural. If the orbit has changed, if there's a deviation, even a small one, then something happened behind the Sun. Either the object maneuvered or it fragmented, or it experienced some other event that altered its trajectory, and that would be significant. Loeb has identified a specific window for detection, November 21st to December 5th. Quote from an earlier blog post. The authors stress that their theory is falsifiable. Should 3I-ATLAS pass through the solar system without performing unexpected maneuvers, particularly between November 21st and December 5th, 2025, the hypothesis would likely be debunked. 2 weeks. That's the critical observation window. If maneuvers happened at perihelion, they would become detectable as trajectory deviations by late November. Astronomers will be watching. But there's another layer to this, the precursor probe theory. In September, Loeb published another calculation. If 3I-ATLAS released a smaller object, a probe, sometime before now, and if that probe was travelling ahead of the main object by about 30 million kilometres, it could have intercepted Mars, this week, October 3rd, the same day as the Mars flyby. The math works. A probe doesn't need to be large. A few metres across, maybe 10, the size of a car. At that scale, reflecting sunlight at Mars distances, it would be invisible to Earth-based telescopes. We couldn't detect it, but it could be there. The high-risk camera on Mars Reconnaissance Orbiter isn't just looking for the main object. According to Loeb's suggestion, it should also be scanning the approach corridor, looking for smaller objects, precursors, scouts. Has NASA done this? We don't know. The imaging plans haven't been made public in that level of detail, but the possibility exists, and if something shows up in the data, something small and unexpected, the conversation shifts instantly. Now, the more likely scenario, the one most scientists expect, is that nothing happens. 3I-ATLAS passes perihelion, continues outbound, fades into the distance. A weird comet. Interesting. Worth studying. But ultimately just another interstellar visitor. No maneuvers, no probes, no deviation. That's the baseline expectation, and it's probably correct. But the geometry is uncomfortable. The timing is uncomfortable. The fact that the most critical moment happens when we can't see it, that's uncomfortable. And if you add the cue ball hypothesis into the mix, it gets worse. Because a cue ball doesn't need propulsion. It doesn't maneuver. It's inert. But it's also massive. 33 billion tons. If it passes close to a planet, it exerts gravitational influence. A planet's orbit could shift, minutely, but measurably over time. Mars is the concern. 3I-ATLAS passes within 29 million kilometres today. That's close, not collision close, but close enough that gravitational interactions matter. If the object is truly as massive as the estimates suggest, Mars should feel a tiny tug. Its orbital elements, the precise parameters that define its path around the Sun, could shift by a detectable amount. Astronomers track Mars constantly. Its position is known to incredible precision. If 3I-ATLAS imparts even a small gravitational perturbation, we'll see it. Not immediately, but over weeks and months as Mars continues its orbit, the deviation will accumulate. That's another test. Another way to confirm or refute the mass estimates, and the results will come in over the next few months. So we wait. October passes, the object hides, November arrives, observations resume, and by December we'll know. Did it maneuver? Did the trajectory change? Is the mass real? The answers are coming, whether we're ready for them or not. Chapter 8. The decoy scenario. There's a theory within the theory, a speculation inside the speculation, and it's possibly the most unsettling one yet. What if 3I-ATLAS is a distraction? The idea came from Omar El-Dadi, a collaborator of Avi Loeb's. He suggested that an advanced civilization might use a natural-looking interstellar comet as a decoy. Something bright, something obvious, something that draws telescopes and attention, while the real operation happens elsewhere. Loeb discussed this in an August blog post. Quote, "My collaborator, Omer Eldadi, suggested that aliens might use a natural interstellar comet as a decoy to attract our attention when they conduct another operation at a different location near Earth. Given that perspective, it would be interesting to check whether there is an enhanced activity of unidentified anomalous phenomena in the Earth's atmosphere in the aftermath of the closest approach of 3I-ATLAS to the Sun on October 31st, 2025. Enhanced UAP activity. Around the time 3I-ATLAS reaches perihelion, that's testable, and someone is testing it. The Galileo Project, Loeb's initiative, an astronomical research program designed to search for evidence of extraterrestrial technology, not through radio signals, not through distant exoplanets, but here, near Earth, using telescopes and sensors to monitor the sky for anomalous objects. The project has 3 observatories, one at Harvard College Observatory in Massachusetts, one in Pennsylvania, one in Nevada, each equipped with cameras, infrared sensors, radar and audio detectors. They scan the entire sky, continuously, recording everything that moves overhead. The system uses artificial intelligence to classify objects: birds, planes, satellites, drones, meteors. Most things are mundane, easily explained. But occasionally something appears that doesn't fit, an object moving too fast, or too slow, or changing direction in ways that conventional aircraft can't. Those are flagged, analysed, investigated. The Galileo project has been operational since late 2022. It's collected data on 500,000 aerial objects. The vast majority are identified, explained, nothing unusual, but the system is there, watching, and according to Loeb, it will be watching closely through October and November. Quote, "Gladly, the Galileo project will be monitoring the sky under my leadership with its 3 observatories in Massachusetts, Pennsylvania, and Nevada during that period." So, if UAP activity increases, something strange starts appearing in Earth's atmosphere, while 3I-ATLAS is behind the Sun, the Galileo project should catch it, and if there's a correlation, if the timing aligns, that would be interesting. Now, let's be clear about what this means. Loeb isn't predicting alien spacecraft will appear. He's not saying 3I-ATLAS is definitely a decoy. He's saying if it were, we should look for secondary activity, and his team is positioned to do that. The decoy hypothesis rests on a few assumptions. First, that 3I-ATLAS is either artificial or controlled. Second, that its purpose isn't direct contact but reconnaissance. Third, that whoever sent it or whoever is using it wants humanity distracted, focused on the big, obvious object, while smaller, stealthier operations happen closer to home. Why would an advanced civilization do that? One reason: information asymmetry. If you're scouting a potentially hostile or unpredictable species, you don't announce yourself. You gather data, quietly. You deploy small probes, low observability, and you ensure the target's attention is elsewhere. 3I-ATLAS is loud, bright, unusual. Every major telescope on Earth and in orbit has looked at it. Papers are being written, scientists are debating, media is covering it. It's a spectacle. And while everyone is looking up at the comet, what's happening down here, in the atmosphere, in orbit? Are there small objects, quiet objects, doing things we're not noticing? The Galileo project data will tell us. Or at least, it will tell us if there's an uptick, a statistical anomaly, more unexplained objects than usual, clustering around late October, early November. If that happens, it doesn't prove the decoy hypothesis. Correlation isn't causation, but it would be hard to ignore. There's another angle, the stealth hybrid spacecraft theory, proposed by Gabor Soker, a reader of Loeb's work. The idea is that an advanced civilization might not build spacecraft from scratch. They might use natural materials, asteroids, comets, terraform them, hollow them out, install machinery inside, use the natural exterior as camouflage. Loeb quoted Soker in his blog, quote, "Humanity is already planning asteroid mining missions, and for a more advanced civilization, this could be a straightforward method. An asteroid hull provides excellent natural shielding. The object offers inherent stealth. As long as there are no active emissions or artificial reflective surfaces, it appears externally to be just a natural asteroid. This solves a problem. If you want to send something to another star system, you need shielding. Cosmic rays, high-energy particles, micrometeorites. Interstellar space is hostile. Building thick walls is expensive, heavy. But if you start with a rock, the shielding is built in. You just excavate the interior, install your systems, and go. From the outside, it looks like a comet. It outgasses. It has a coma. It behaves normally. But inside, there's machinery, instruments, power sources, maybe even crew, dormant, waiting. This isn't new speculation. Science fiction has used this idea for decades. Arthur C. Clarke's Rendezvous with Rama, a massive cylindrical spacecraft disguised as an asteroid. Greg Bear's Forge of God, self-replicating machines hidden inside comets. The concept is familiar. But it's also practical. If you're crossing interstellar distances, if you're spending millennia in transit, using natural materials makes sense, and it makes detection harder, because astronomers assume rocks are rocks. Unless they do something obviously artificial, they get classified as natural. 3I-ATLAS hasn't done anything obviously artificial. No radio signals, no course corrections, no artificial lights. It just doesn't quite fit the data. The chemistry is off, the physics is off, the trajectory is suspicious, but none of that is proof. That's the brilliance of a stealth hybrid design. It's deniable, ambiguous. You can't prove it's artificial without getting close. Very close. And by the time you could launch a mission to intercept it, it's already gone. So we're left with questions. Is the Galileo project going to see something unusual in the coming weeks? Will UAP reports increase? Will there be objects that don't fit? And if so, will anyone connect them to 3I-ATLAS? Or will October and November pass quietly? No anomalies, no uptick. Just a comet passing behind the sun and re-emerging on the other side. Strange, yes, but ultimately natural. The data will answer, one way or another. We just have to wait a few more weeks. Chapter 9. The Silence Protocol. The scientific community is fractured over this object. Not openly, not in press conferences or official statements, but in the quieter spaces. The email chains, the conference hallway conversations, the late-night lab discussions. There are two camps, and the gap between them is widening. One side says 3I-ATLAS is a comet. Unusual, yes, pushing boundaries, but still within the realm of natural phenomena. The chemistry can be explained with exotic parent molecules we haven't identified yet. The mass estimates might be wrong. Better data will clarify. Patience and rigorous science will resolve the anomalies. The other side is less certain. They see the same data. They run the same calculations, and they're getting answers that don't fit, not just at the edges, at the core. The physics doesn't work unless you accept premises that seem impossible. Massive density, internal energy sources, synthetic chemistry. The leaked 4chan post speaks to this divide. Quote, "The official position is that 3I-ATLAS is a uniquely active but otherwise natural comet. This position is no longer tenable, and the silence from leadership on the cognitive dissonance this requires is becoming a serious professional issue for a growing number of us." Cognitive dissonance. That's a strong phrase. It means holding two contradictory beliefs simultaneously. In this case, believing the data is accurate while also believing the object is natural, because if the data is right, natural doesn't fit, and if natural is right, the data must be wrong. But the data has been checked repeatedly by multiple independent teams using different instruments, different methods, and it keeps coming back the same. So where does that leave the researchers who can't reconcile it? According to the post, they're being discouraged from discussing alternatives, not forbidden, not censored, just discouraged. The professional incentives push toward conventional explanations. Papers that propose exotic hypotheses get harsher reviews. Grants that mention terms like artificial or non-natural face skepticism, careers can stall. This isn't unique to 3I-ATLAS. It's a broader issue in science. The pressure to stay within accepted frameworks, to not rock the boat, to be conservative in claims. Most of the time, this is healthy. It prevents wild speculation from drowning out solid work. But occasionally it creates blind spots, places where the data is pointing one way and the community is looking another. Jason Wright, an astronomer at Penn State, has been vocal about this. He's criticised Avi Loeb's approach to 3I-ATLAS and previously to Oumuamua. He argues that Loeb is too quick to invoke artificial explanations, that he dismisses basic observations, that his claims get media attention but don't hold up under scrutiny. Wright wrote in a blog post, quote, "Avi Loeb has gained a reputation for suggesting and outright claiming things could be alien spacecraft. even when there's little to no objective reason to think so. It didn't take long before Avi Loeb claimed 3I-ATLAS was an alien spacecraft. He goes on to critique specific claims. The idea that the extended source observed by telescopes is just image smearing. Wright points out that modern telescopes compensate for object motion. They track. They stack images. Smearing isn't an issue for professional observatories. If multiple independent observations show an extended source, it's real. 3I-ATLAS has a coma. That makes it a comet. But Loeb's response is more nuanced than Wright's critique suggests. Loeb isn't claiming certainty. He's proposing a scale, a framework, the Loeb scale, 0 to 10, where 0 is definitely natural and 10 is definitely artificial. He rates 3I-ATLAS at 6. Not definite, not proven, but high enough to warrant serious investigation. The scale itself is interesting. It's designed to move the conversation away from binary thinking. Not, is it alien or not? But how anomalous is it? How much does it deviate from expectations? And what level of anomaly triggers what kind of response? Loeb has proposed that this scale be adopted formally by an international body, specifically the United Nations. In October, a white paper was submitted, authored by Omar El-Dadir, Gershon Tenenbaum and Avi Loeb, titled Advancing Interstellar Science, a global framework for comprehensive study of interstellar objects. It proposes the creation of UNCIO, the United Nations Committee on Interstellar Objects. The idea is straightforward. As detection capabilities improve, particularly with the Vera Rubin Observatory coming online, we're going to find more interstellar objects, many more. The estimates suggest one every few months, maybe more. Each one is a fleeting opportunity. They pass through quickly. If we want to study them, we need coordination, international, rapid, pre-planned. UNCIO would standardize the response, establish protocols, create a network of observatories with guaranteed observation time, maintain a fleet of rapid response spacecraft ready to launch on short notice, and crucially, implement the Loeb scale as the official classification system. Objects rated 4 or above would trigger enhanced observation. Level 6 would require notification of the UN Security Council. Level 8 or higher would activate emergency protocols. 3I-ATLAS currently sits at 6. If it maneuvers, if gamma rays are detected, if the activity continues independent of solar distance, the rating would rise, and the international response would escalate accordingly. The proposal is ambitious. It requires funding, political will, cooperation between space agencies. None of that is guaranteed, but the framework is there, and Representative Anna Paulina Luna, a US Congresswoman, has endorsed it. Her letter of support is cited in the white paper. Whether UNCIO becomes reality depends on how the next few months unfold. If 3I-ATLAS fades quietly into the distance, the urgency diminishes. It becomes an interesting case study, a weird comet, worth a paper, but not a crisis. If something changes, if the object behaves in ways that can't be explained, the conversation shifts, and suddenly international coordination doesn't sound like bureaucratic overreach. It sounds necessary. The other element at play is transparency, or the lack of it. The 4chan post hints at internal conversations that aren't public, data that hasn't been released, frustrations that haven't been aired. If that's true, if there's a gap between what scientists are saying privately and what's being stated officially, that gap will eventually close, either through leaks or through formal disclosure. The scientific method relies on openness. Data should be shared. Hypotheses should be tested publicly. Peer review should be transparent. When that breaks down, when information is siloed or controlled, trust erodes, and speculation fills the void. Right now, we're in a strange middle ground. Enough data is public to raise questions, but not enough to answer them definitively. The critical observations, the Mars flyby images, the gamma ray searches, the December trajectory measurements, those are still pending. And in that gap, people are watching, waiting, some with telescopes, some with theories, and a few allegedly with knowledge they're not supposed to share. The next chapter in this story isn't going to be written by speculation. It's going to be written by data, by observations, by measurements that either confirm the conventional explanation or force us to consider alternatives. We're close now. The Mars flyby happened today. The perihelion window is 3 weeks away. The December emergence is 2 months out. By the end of the year, we'll know more. Maybe not everything, but more. And if the anomalies persist, if the data keeps refusing to cooperate, then the silence protocol, whatever form it takes, won't hold. Because eventually the walls we build around uncomfortable questions start to crack, and the shape of the room becomes visible, whether we're ready to see it or not. Chapter 10. What happens next? The images from Mars should arrive within days, maybe a week. The Mars Reconnaissance Orbiter has transmitted its data back to Earth. Engineers are processing it, calibrating, enhancing. Soon, we'll see what HiRISE captured during the flyby. If the nucleus is clearly visible, if it's 5 kilometers or larger, the mass debate intensifies. 33 billion tons becomes harder to dismiss. The statistical anomaly of finding something that massive becomes unavoidable. Either interstellar space is far more crowded than we thought, or this object is exceptional in ways we don't understand. If the nucleus is smaller, under a kilometer, the mystery shifts. Because a small nucleus producing this much outgassing, staying this bright at this distance, that's a different kind of problem. It suggests extraordinary activity, internal heat, something driving the emissions beyond simple solar warming. Either outcome raises questions, neither outcome resolves them. The spectroscopic data from Mars Express and ExoMars Trace Gas Orbiter will add another layer. They're measuring the gas composition from a different angle, closer, with instruments designed for atmospheric analysis. If they detect compounds that weren't visible from Earth-based telescopes, if the chemistry looks even stranger up close, that matters. Then there's the brightness monitoring. As 3I-ATLAS moves away from Mars, continues toward perihelion, observers on Earth have a narrowing window. Mid-October, the object disappears into solar glare. Until then, every night of photometry counts, every spectrum, every polarization measurement. Teams around the world are collecting data, archiving it, building a timeline. When the object re-emerges in December, that timeline becomes critical. We'll compare the pre-perihelion behavior to the post-perihelion behavior. Does the activity curve match predictions, or does it deviate? A normal comet follows a power law. Brightness and outgassing increase as the inverse square of solar distance, or steeper. Approaching the sun, activity rises. Receding, it falls, predictable, universal. If 3I-ATLAS doesn't follow that curve, if the activity stays high as it moves past 3 astronomical units, past 4, that's a red flag. The cue ball prediction, as mentioned earlier, hinges on this. An internal energy source doesn't care about solar distance. It's constant. That's falsifiable, testable. We'll know by January or February. The gamma-ray search is another thread. Observatories like Fermi and Integral scan the sky continuously. They detect high-energy photons. If 3I-ATLAS has an internal particle physics process, a decay mechanism producing high-energy particles, those instruments should see it. So far, no public reports of gamma-ray emission from 3I-ATLAS. That doesn't mean searches aren't happening. Data takes time to analyze. Signals are faint. Background noise is high. A detection might not be announced immediately, or it might be sitting in a dataset waiting for someone to notice. If gamma rays are detected, and if they correlate with the comet's position, and if they can't be explained by solar-wind interactions or cosmic ray impacts, that's a game changer. No natural comet emits gamma rays from internal processes. Only astrophysical engines do. Pulsars, magnetars, supernovae, or potentially exotic matter. Mars orbital perturbations are a slower signal. Mars is tracked with extreme precision. Its orbit is known to meters. If 3I-ATLAS exerted a gravitational pull during the close pass, Mars will drift slightly off its predicted path. Not much, millimeters per day, but over months that adds up. By early 2026, the deviation, if real, should be measurable, and if it matches the expected perturbation from a 33 billion ton object, that's independent confirmation of the mass. No outgassing chemistry required, just gravity. The UAP monitoring through Galileo Project observatories is live. Right now, data is being collected. If there's a spike in unexplained aerial phenomena coinciding with the perihelion passage, we'll see it in the statistics. More objects, unusual trajectories, clustering in time. Absence of a spike doesn't disprove the decoy hypothesis. It just removes one line of supporting evidence. but presence of a spike would be hard to ignore, especially if the anomalies are concentrated in late October, early November, and then taper off. And then there's December 5th, the end of Loeb's specified detection window for trajectory changes. If 3I-ATLAS manoeuvred at perihelion, if it performed a reverse O-berth to stay bound to the solar system, the deviation should be detectable by then. Observatories will measure the object's position, calculate its orbit, compare to predictions. If the orbit is unchanged, purely gravitational, then no maneuver occurred. The object passed perihelion naturally. It's leaving. Whatever it is, it's not staying. If the orbit changed, if there's a deviation that can't be explained by outgassing or fragmentation, then something happened behind the sun, something we couldn't see, and that demands explanation. The Vera Rubin Observatory adds a final twist. It began operations this year. Full sky surveys, deep imaging, automated detection. It's designed to find transient objects, moving things, asteroids, comets, and interstellar visitors. The models predict Rubin will detect one interstellar object every few months, maybe more. Within a year or two, we'll have dozens, each one a data point, a comparison. Is 3I-ATLAS unique, or is it part of a population? If future interstellar objects show similar anomalies, extreme mass, unusual chemistry, constant brightness, then 3I-ATLAS isn't an outlier, it's a preview. A first look at something common in the galaxy that we've only just started noticing. If future objects are all normal, small, well-behaved comets, then 3I-ATLAS stands alone, an exception, which makes it more mysterious, not less. The bigger picture is this. We're at an inflection point. For the first time, we have the tools to study interstellar visitors in detail, not just detect them, study them. Spectroscopy, high-resolution imaging, rapid response missions, international coordination. 3I-ATLAS is a stress test. It's pushing every instrument, every model, every assumption, and in doing so, it's revealing gaps, places where our understanding is thinner than we thought. Some of those gaps will close. Better data, refined theories, natural explanations that we haven't considered yet. Science has a way of resolving anomalies, not always quickly, but eventually. Other gaps might not close. They might widen, become chasms, and at that point the conversation changes fundamentally, from what kind of comet is this to what is this? We're not there yet, but we're close enough to see the edge. The next 3 months will be telling. Mars images, perihelion passage, gamma-ray searches, December re-emergence, trajectory measurements, UAP data. Each piece adds to the puzzle, or complicates it further. By the time we reach March, when 3I-ATLAS passes Jupiter and the Juno spacecraft gets its look, we'll have a much clearer picture. Not complete, but clearer. And if by then the object is still defying explanation, still sitting at a 6 or higher on the Loeb scale, the silence protocol breaks. The questions become too loud, the data too persistent. And we'll have to confront what the 4chan leaker said, that this isn't a failure of our models, it's a glimpse of something underneath them, something we didn't know was there. Whether that something is exotic astrophysics, dark matter, ancient relics, or something else entirely, we're about to find out. The universe is patient, it doesn't rush, but it also doesn't hide. If 3I-ATLAS has a secret, if there's machinery under the surface, it will show itself. Through the data, through the observations, through the slow accumulation of evidence that either confirms or denies. We just have to watch, and wait, and be willing to follow where the data leads, even if it leads somewhere uncomfortable. Because that's what science is, not a set of answers, a method for asking better questions, and 3I-ATLAS is asking the best question we've heard in a long time. What are you? So, here we are, at the end of a story that hasn't finished yet. October 3rd, 2025. The Mars flyby happened hours ago. Data is streaming back, and somewhere in that data maybe is an answer, or at least the beginning of one. Let's take a breath and think about what we've covered. 3I-ATLAS, an interstellar visitor, the third one we've ever confirmed. But unlike the previous two, this one refuses to behave. It vents 150 kilograms per second with no recoil. It has the mass of a small moon compressed into a space no larger than Manhattan. It streams nickel at temperatures where nickel should be frozen solid. Nickel tetracarbonyl, a synthetic industrial chemical, appears in its spectrum. The dust it sheds has polarization properties so extreme that scientists thought their instruments were broken. It doesn't rotate, or if it does, the brightness never changes. It absorbs gigawatts of solar power and stays cold, and its trajectory, its timing, its alignment with the planets, all of it sits at probability levels that make statisticians uncomfortable. 7 anomalies, 4 that might be explainable, 3 that won't go away no matter how much data we collect. And then there's the leak. The anonymous post from someone claiming to work with the European Space Agency, describing a working group that has tried and failed to reconcile this object with any known natural body, describing chemistry that shouldn't exist on a rock billions of years old, dust that looks manufactured, a thermal budget that doesn't balance, and a conclusion that's being discouraged from discussion, that maybe, just maybe, this isn't debris at all. The cue ball hypothesis, a macroscopic quantum object from the Big Bang, a bubble of different physics wrapped in ice and dust, slowly decaying over billions of years, an internal engine that doesn't need the sun, that produces exotic chemistry as exhaust, that outgasses symmetrically, violently with zero net thrust. It sounds like science fiction, but according to the leak, is the only framework that makes all the data fit. The only physics that turns a system of wrongness into something coherent. And it's testable. 2 predictions, simple, falsifiable. Watch the object as it leaves the solar system. If the activity stays high, independent of distance, that's the first sign. Point a gamma-ray telescope at it. If there's a non-thermal high-energy signature, that's the second. Both predictions will be checked in the coming months. Then there's the hidden window. 26 days from now, 3I-ATLAS disappears behind the sun. Perihelion happens on October 29th. The perfect moment for a maneuver, if maneuvers are possible. The perfect moment to release probes, if probes exist. And we won't see any of it. Not until December, when the object re-emerges. And we check the trajectory. Did it change? Did something happen? You see, the decoy theory adds another layer. Maybe the comet is a distraction. Something loud and obvious, drawing attention, while the real reconnaissance happens closer to Earth. The Galileo project is watching for that. 3 observatories scanning the sky, looking for an uptick in unexplained phenomena around the time of perihelion. If it's there, the data will show it. And underneath all of this, the scientific community is fracturing. Not openly, not in press releases, but in the quiet spaces. Some insist it's a comet, unusual but natural. Others see the data and can't make it fit. The cognitive dissonance is becoming a professional issue, according to the leak, and the silence from leadership is growing louder. A proposal has been made. UNCIO, the United Nations Committee on Interstellar Objects, a framework for international coordination. The Loeb scale as the official classification system, protocols for rapid response, observation networks, even spacecraft ready to launch on short notice when the next visitor arrives, because the next one is coming. The Vera Rubin Observatory guarantees it. 1 interstellar object every few months, maybe more, and each one is an opportunity, or a warning. 3I-ATLAS currently sits at a 6 on the Loeb scale, high enough to warrant serious investigation, not high enough to trigger emergency protocols. But if the predictions hold, if gamma rays are detected, if the trajectory changes, if the activity persists, the rating rises, and the conversation escalates. We're about to learn something. In the next 3 months, maybe sooner, data will come in that either confirms the conventional explanation or forces us toward alternatives. Mars images will show the nucleus, large or small. Spectroscopy will refine the chemistry. Trajectory measurements in December will reveal if anything happened behind the sun. Gamma-ray searches will either find a signal or rule it out. The Galileo project will either detect a UAP spike or it won't. And by spring, when 3I-ATLAS passes Jupiter and Juno gets a close look, we'll have a comprehensive data set, enough to say, with confidence, what this object is, or at least, what it isn't. The universe doesn't lie. It doesn't hide its secrets forever. If 3I-ATLAS is just a comet, a strange one but natural, the data will converge on that answer. The anomalies will resolve, the models will adjust, and we'll move on. But if the data keeps refusing to cooperate, If every new observation adds another layer of strangeness, if the system of wrongness persists and deepens, then we have to follow where it leads, even if it's uncomfortable, even if it challenges everything we thought we knew about what drifts between the stars. Because that's the promise of science. Not comfort, not certainty, but truth, however strange it turns out to be. Thank you for listening, for staying with this story through all its twists and uncomfortable questions. If you found this valuable, hit that like button. Subscribe if you haven't already. It helps more than you know. And in the comments, tell me, are you convinced this is just a comet? Or is there something here that doesn't fit? What do you think we're looking at? This video is for entertainment and educational purposes. The views expressed, especially regarding the 4chan leak and speculative theories, do not represent scientific consensus. Always consult peer-reviewed sources and official space agency statements for verified information. Until next time, keep watching the skies, because something is out there, moving through the darkness, and in a few short months we'll know a little more about what it is. Good night.